Good morning, all. So today we will start the topic called the second topic in the path reductions and regular expression. The second topic is the reduction procedure. Here we will discuss about the reduction procedure. So reduction procedure is nothing but here we will So in this reduction procedure, in this section we will discuss about the about the representation of the path expression. So already we have seen how to represent the path expression. So representation of the path expression is nothing but representing the paths according to in the expression format. For example, see here in the previous class, we have seen the representation. This is nothing but AB star C equal to AC plus ABC. This is nothing but the representation of the path expressions. That is called the representation. You have directly mentioned by seeing the flow graph. Okay, but now we will do in the procedure format by doing the reduction procedure. So then in the name itself, we will do the reduction process. That is nothing but removing the one by one nodes and producing a path expression, adding that nodes to one path to the other path, one path to the other path, and finally we are producing the path expression. So reduction procedure is nothing but converting a flow graph. It will convert the flow graph whose links are labeled with names. So generally the reduction will be done to the nodes which have the links, names with the links. That means A, B, C, the links, the name of the link will be like this. So which contains the type of names with the links that will be reduced, that will be converted into a path expression. Okay, that denotes the set of all entry paths in the flow graph. So this path expression starts from the entry point to the exit point. From entry point to the exit point, this procedure will be started, and reduction after completion of all nodes reduction, we finally get the path expression. That is the main agenda of the reduction procedure. So reduction procedure is nothing but converting a flow graph with the link names with the links with the names and converting into a path expression from entry point to the exit point is called the reduction procedure. Okay, so the reduction is generally done by node removal algorithm. So the reduction procedure, how it will be performed? It will be performed by node removal. First we remove, finally the path expression will be generated after all completion of the node removal is completed. So if first initially one node is removed, means then that particular node related path is added to the remaining nodes. Then next node will be removed. This will be repeatedly done up to the entry and exit points. Okay, so entry and exit points is the last point where links. So these have we seen in the last example. See here in these loops, these are called the parallel links. So serial links or AC is the serial links. Okay, so first of all, when you're performing a path expression or you're performing a reduction procedure, need to identify what are the serial links and what are the parallel links. When these are the serial links, when you are identified as a serial links, you need to multiply the two links. When you're producing a path expression, serial links has to be multiplied. That means if you have a serial links with the link names A and B, then that has, when you're representing the path expression, that has to be represented as A, B. Okay, A into B has to be done. So finally in the, it should be seen in the path expression as AB. So when A and B are the parallel links, that has to be added like A plus B. Okay, so serial links has to be multiplied, whereas parallel links has to be added. So the next link is loop link. First one is you need to identify what is the serial links. Next, what are the parallel links? If it is a serial links, you need to multiply. If it is a parallel links, you need to add that links. And next one is loop link. The links can be also in loop format also. Okay, loops. So when they are in loop self loops, so that has to be done repeatedly. That has to be done repeatedly, and it is to be represented with the in the power star. Okay, for example, x is a self loop, so it has to be replaced by x star, where x is the path expression of the link in that loop. Okay, it has to be represented with x star. Serial link has to be multiplied, parallel links has to be added. When it is a self loop, it has to be represented with the star. Okay, so these are the 3 points. First, while you are going to the reduction process, this 3 point has to be in your mind. So the next one is, so next we will go for what is how the next we have to go for the remaining steps. So remaining 4 to 8 steps or reduction process will be started. So first we need to find the nodes. Next, the reduction process will be started according to the nodes. So from which point the reduction has to be started? For example, we have from entry to exit points, we have 10 links. From which point that link, that reduction node has to be started. From that, we have to reduction procedure has to be done one by one node. Okay, so generally the reduction procedure will be start from the last node. Okay, so entry and exit nodes should not be taken for the reduction process initially. So see, select any node from the removal other than initial and final node. From fourth step, after identifying the links, the reduction when the reduction node started, you can take randomly any link, but actually we will take the last from the last link. We will take the procedure from the last link to the first link. Okay, so in when you're taking when you're starting the reduction procedure, we should not take the initial and the final load as the first reduction link. Then multiplications will be done, parallel links addition will be done, self loop means loop repetition will be done by use it has to be represented with the star. Okay, next, while coming to the remain point, reduction points, first we have to do the reduction process of the node from last. Generally, we will go from the last to the first. Initially, we should not take the nodes of entry point and exit points. And after the node is reduced, then that path expression will be set to the inlinks with an outset of the outlinks of the nodes. That particular path expression, for example, you are removing the node 10, it gets the a plus b as a path expression. So that path expression is added to the inlink of the 10 and outlink of the 10. For example, the inlink of the 10 is 8, the outlink of the 10 is outlink of the 10 is some loop 7. Okay, so for 7 and 8, this a plus b will be added as the links. Okay, so the next one, combine any remaining serial links by multiplying their path expressions. If there is any serial links continue to that, it will add to that path expressions. And parallel links, if it has a parallel links for that particular node, we will do the parallel links. Okay, if it is a self means self will be self loop will be removed. Okay, so the graph consists of single link between the entry and exit point. Generally, the entry and exit point will have only a single incoming link or single out link. So when this type of nodes will be arises, then path expression of that link in the path expression to the original link. So that process will be done. That means that is the last process. Then the starting process will be started. Again, removal node is present again. So this removing of the nodes will be repeatedly done until the all nodes will be removed. So this algorithm we will see in with an example. So this is a reduction procedure that has to be applied to this flow graph. For example, this is a flow graph which consists from 10 to 11. Sorry, 1 to 10. Here entry node is 1, exit node is 2. Not compulsory. The entry node should not be should be 1, then exit node should be 10. It is not compulsory. Okay. Okay. The entry point can be anything. The exit point can be anything. For example, 1 is an entry point, 2 is an exit point. 1 is an entry point, 2 is an exit point. So from 1 to 2, the nodes which you are going to be removed should not be 1 and 2 initially. If remaining any node you can take and we can remove that one. Generally we go for last, or we will see the last admit node and the last loop. First we will take the loop node. Is there any loops? First we will remove that loop nodes. Okay. So generally here 10 is the loop node. Generally 10 is the loop node. 10 is the loop node. Here this loop will be, here this 10 node will be removed. See, here you are removing the 10 node. Let us see the algorithm to following graph. We are removing several nodes in order. Okay. So 10 node will be removed first. While you are removing the 10 node, you have to check what is the incoming node and what is the outgoing node. So what is the incoming node for this particular 10? So incoming node is coming from the 6, outgoing is going to the 11. So this is the loop representation. See, 10 will start, it goes for 7, 3, 6. Again, this repetition will be done. Okay. So first here we have to see what are the incoming nodes and what are the outgoing nodes. So incoming node is coming from the 6, outgoing is going to 7, followed by the 3, 4, 5, 6. Now we need to identify what are the serial nodes and what are the next parallel nodes. What are the serial nodes here? We will need to identify, and that serial nodes has to be multiplied. When it contains a parallel nodes, we have to go for addition. If it contains a loop, self loop is there, then we will go for star. Okay. See here, we are removing the 10th node. So this will be this. First, we will remove the 10th node by applying the step 4. From the node removal, it starts from the step 4 to step 8. Okay. So from step 4, first we are removing the node. First, we will write the what are the connections, incoming connections and outgoing connections to that particular node. So 6 for 10, it comes 6, 10, 9. Okay. 6, 10, 9. So from 6, see the incoming node of the 10 is 6. The outgoing node of 10 is from to 9 or to 7. So we will write the two cases of the outgoing of the 10 node. So 6, 10, 9 and 6, 10, 7 are the two possible ways of representing the links. Okay, 6, 10, 9 and 6, 10, 7. So when you are removing the 10th node, what will be the final connections will be is 6 to 9 and 6 to 7. 10 is removed means 6 will goes to 9. In between 10 it is reduced 6 to 9 and 6 to 7. So what are the links that are represented to the 10 is, so 10 contains a link M, 6 to 9, 6 to 10 it has a link name I and node and link name I, whereas 10 to 7 it have M, whereas 10 to 9 it has L. So when you are removing the 10 node, so you need to see it is a I and L. So for example, we are saying 6, 10, 9. The links are I and L. Okay, this I, L or serial or parallel, you need to check there. So here I and L or serial means that way you will go for multiplication. That means I, L multiplication. IL. See, IL will be the next weightage of the node. Okay. Next, when 10 to 7, so 10 to 6 to 10, 10 to 7. Again, what are the nodes of this particular 6 to 10 and 10 to 7? I, M. So again, these two are again parallel nodes. Parallel nodes are nothing but it is a continuous format. Okay. So that is I7. Again, it is a multiplication process. Then it is represented as IEM. Okay. These are the final links has to be represented after the 10 node is removed. So when you are removing 10, 6 to 9 connection will be produced. Then the link name is IL. And when you are removing the node from 6 to 7, 10 node is removed. Then the link is 6 to 7 and the link name is IM. Okay. See here diagram. So we are removing the 10th node. See, 10th node is removed. So then the connection is goes to 6 to 9 and 6 to 7. When 6 to 9, it is you are joining incoming from outgoing to 6 to 9, then it will be IL. When it going to 6 to 7, then it will be IL. This is the process of reducing the nodes. After removing the 10th node, we will go for the next node. Here the next node I am removing is ninth node. In the sequence process, I'm going to remove it. Okay. So it is going to the ninth node. So now again, you need to check the what are the incoming nodes, what are the outgoing nodes of the ninth. So the incoming nodes of the incoming and outgoing, the two paths that generated from the 9 is 8, 9, 5. So see here, 8 is not goes to 8 goes to 7 as well as 8 go to 9. So here the incoming node of 9 is 8. The outgoing node of 9 is the outgoing link of 9 is 5. Okay. So 8, 9, 5 again. So 9 uh, it is any path from again this particular 9 means 6, 9, 5. Okay. 6, 9, 5 is the again two paths can be generated as the middle of the as the middle node 9. Okay. So when you are going to this path 8, 9, 5, when you're removing the 9, the final new path is generated is links generated from 8 to 5. So 8 to 5. See here when you're seeing 8, 9, 5 as a path, the links are K and H. So these two are again in the serial way, then they two are multiplied, K and H. So again like that, 695 695 initially after removing the 10th node, the new weight the new link name is IL, okay, to 629. So that has to be multiplied with the another one. So IL H again they two are serial, then these two are again multiplied. Then after generating the new link names, we will remove the 9th node and we will generate the new link and we'll add the new link names to the remaining nodes. Okay. 6 to 8. After removing the 9th node, the connection will be produced to 6 to 5. Okay. 6 to 5 with KH link name. 8 to 5 with KH link name. 6 to 5 with ILH link name. So this process will be repeatedly done until you reaches to the entry point and exit point. Okay. After removing the 9, going to remove the 7th node. Okay. So 7th node, what are the path that will produce from the 7th? See here, 6, 7. So the node which you are going to remove, that should be in the middle. Okay. So we will say that means you are taking that removing node will be middle means incoming node, and left side it will be the incoming node and right side will be the outgoing node. Like that you need to see the path. Okay. So the what are the path of this particular 7? 6, 7, 3 and 8, 7, 3. So 6, 7, 3 considered IM. So here forgot, here is F. So while removing the node 7, we will get the new path, new link 6 to 3 with IM F. Next, removing the 7 with this particular node 873 JF. These are the new nodes. See here. So removing the nodes, we will get A73, 83, A673, 63, 83 JF, 63 IMF. That will be represented here. Okay. So 83 link is JF with name, link name JF, 63 with the link name IMF. Next process is going to the reduction of 8. So after going to the 8, what again the process will be repeated. The repetition process will be started. See here. 8, what are the links path that will be generated? See, incoming link for 8 is 4, 4, 8, 3, again 4, 8, 5. These are the two links. Okay. For 4, 8, 3, when you're removing this particular node 8, we will get the new link path called 4, 8, 4, 3. See, 4, 3. So these what are the link names for 4, 8 and 8, 3? G, JF. Okay. These two are again serial links. Then this has to be multiplied. G, JF. When you're removing this 8th node, the connection will goes to the 4 to 3. Okay. So while after removing, these has to be all represented in the dotted lines. That means they are removed means. Okay. So next 4, 5. So J, KH, J, KH. Okay. Next. Next. See here, all parts are removed. All remaining parts are removed. So these are the all parallel paths. Okay. So now see this for 3, 4 J GF is a parallel path to B. Again, serial paths are all removed. Now you need to go for parallel path removal. So when you are going to parallel path removal, up to now, when serial paths are removed, serial nodes are removed, you are going to multiply all the links. Now you will go, when you are going for parallels, need to add these all link names. Okay. See, now we will going to remove the node 4. So when you're removing the node 4, why I'm taking the node 4 means nothing but it is the middle, which is the heads of the loop term. So for producing the loop, see, for 4, 3, 4, this is again a parallel path, this is an again parallel path. We are taking one node called node 4. So loop node, we are taking the loop node. Okay. See, repetition process will be taken. So that's why I'm removing the loop node first, 4. Okay. Loop is nothing but repetition of the same node. See, so what is the link between the, while removing the fourth node, what will be the path, what is the incoming and outgoing paths? So first one is 3, 4, 3. Again there is another link. Yes, there is another link, 3, 4. So there is another path, 3, 4, 5. Okay, so here first path 3, 4, 3 has 3 is a loop repetition. While you are going for removal of the loop repetition, it has to be represented with the star representation. Okay, so what is the link weightage? See, these two B and J, G, J, F or two both are parallel. Okay, that's why you are sorry, they two are sequential. Okay, so see, continuous format. So they are B, J, F, G. So what is the difference between parallel? What is difference between continuous means? See here, J, G, F, after continuing you going to B, but it is a loop, not like that. If it is not like that, so B is not a link, B is not a link with 3, 4. Instead of 3, 4, it is 4, 3. Then they are called the parallel link. Okay. Sequential link is nothing but continuous link is called the sequential link. Okay. So again, it is a sequential link. B, J, F, G. So, but it is a loop preparation. That's why it is represented with star. Next, next path is 3, 4, 5. 3, 4, 5. So see. So while removing the node 4, we'll go to 3 to 5. 3 to this 3 to 5. Okay. So what are the weightages that we have, links name that we have from 3 to 5? We have B from 3 to 4. 4 to 5 we have C plus G, K, H. Okay. See how the C plus G H is got means, before the removing of node, after removing the node 8, we have removed the parallel terms. See here, removing all parallel terms. What are the parallel terms? See here. So this is a parallel term from 4 to 5 and again 4 to 5. We have two links. See, two are both representing in the same way only. Okay, 4 to 5 and 4 to 5. They are called as parallel links. That is removed here. That's why it is represented as C plus G, K, H. Is clear? So that will be multiplied with the sequence of B. Okay, B into C, B of C plus G, K, H. Okay, so this is the sequential path. Next, after removing the node 4, finally we will get this diagram. See here, we will removing the node 4. The links goes 3 to 5. This 3 to 5 with this particular link name. Next, 3 to 3. There is no 3. It is a loop. No, that is not represented here. It is represented as the sequence path. Okay. So that is the removed of node. Next, we will go to the next removal. See here. So here we're removing the node 5. So we're going to the removing node 5. So in this node 5, what are the, why again we are going for node 5 means it is again a loop. See, 5, 6, 5. Okay. Loop. That's why we're going to node 5. Initially you can go for node 5, then you can also go for node 4. It's your option, but you are taking after removal of all serial, then removal of parallel, then we will go for loop. Okay, see here what is the path for 3 to 5. So path for 5, we have 6, 5, 6 is 1. Next one, 3, 5, 6. Okay. Or 5, 6, 5 or 6, 5, 6. Anything. 6, 5, 6. Okay. So here 3, 5, 6. So when you're removing a node 5, then it goes to 3, 6. See 3, 6. This is the link name for 3 to 5. And D is the sequential for this. So we are going to multiply with this link name. Then the link name for 3 to 6 is, after removing node 5, this is the link name. BG JF star B of 6C plus GKH of D sequence. Next one is this removal. Next one you are going to be taken 6, 5, 6. By your 6, 5, 6. See here. What is the link? IJH, and these two are again loop representation. Okay. That's why you are multiplying D. And it is a loop. That's why it is represented with star and is represented with this representation. Okay. Next. After removing 5, we are going to remove the 6th node. So 6th node removal is generally done because of this is the self loop. We can generally remove this can be done by generally removal. Okay. See here. Remove the node 6. Before going to 6, we have removed the, I think, node 3. See, node 3. See node 3. So, 3. What are the paths of the node 3? 6, 3, 6 and 6, 3, 6 and 1, 3, 6. 1, 3, 6. 6, 3, 6 and 1, 3, 6. Okay. So 1, 3, 6, this will be the sequence path again, A into this particular link name. So followed by the remaining. Next one 3, 6, 6. See, in 3, 6, 6, 6 is a loop representation. Okay. That has to be represented with the loop. See here, that has to be represented with the loop representation. Okay. Finally, this will, after removing the third node also, after the removing the third node also, we have only the 3 nodes called 1, 6, 2. So here 1 and 6 both are entry and exit point, and 6 is the only the node that is called the self node. Okay. So in the last point, see here in the last point, after removing all, so after removing all self loops as in term 3, the original flow otherwise goes to the step 4. So links between the entry and exit points. So now we will go for the last point. Here we does not have any, this one does not have any two links. It does not have any two links. Either it have only the outlink, it have two will have the only in link. Now we will go to remove the 6th node. 6th node is generally removed by the when it is a sequence, it will be multiplied. When it is a loop, it is represented with the star. Only the representation will be done like that. So that because there is no other incoming nodes and outgoing nodes for 1 and 2. Okay. So finally the 6 is represented after removing the 6. This is the finally path expression that has to be that is represented. Okay. This is the reduction process has to be followed.